Okay, so remember the gas laws. You can have them ready next to you. And the first thing that you want to do, as always, is identify what class. What is the first thing you want to identify in a problem? What is given, right? So let's underline all the data that is given. What is the first thing that you get jumps out? Yep. Okay, 2.5 liters, right? What unit is 2.5 liters? What measurement is that? It's your volume. So that's your first volume. And then I have a gas pressure of 4.6 atms. That's my pressure. The next thing is, if the volume is decreased to 1.6 liters, so that is your volume 2, what is the new pressure? And you highlight new pressure in a different color because that is your unknown. So I have a formula that involves both volume 1, volume 2, and pressure. From your formula sheets, which formula can you use? Pressure 1 times volume 1 equals pressure 2 times volume 2. That's right. So Borel's law. So here's your formula. And the next thing that you do once you have your formula, you plug in the numbers. So your P1 is 4.6. Your V1 is 2.5. Just make sure the units are the same on both sides. Your P2, I don't know what it is, so just write down P2. And your volume 2 is 1.6 liters. Okay, so you have number 1, the formula, number 2, and then number 3, how do I rewrite it to solve for P2? How do I solve it? How do I rewrite it to solve it? What do I need to do? .6 times 2.5 divided by 1.6, right? That's my P2. Take your calculator. .187. Let's see, how many significant figures do I have here? 2, right? 2 and 5. How many do I have here? Also 2, 4 and 6. And 1 and 6, so I bring it down to 2 sig figs. So instead of 7.187, I write down 7.2 ATM. And that is your answer. And that's how you work each one of them. So you find the formula since you're using pressure and volume. You find a formula that correlates pressure and volume. Okay, excellent. Let's look at the second problem. So the first one was Borel's law. This is the formula. Miss Hunter is